Hi, so we're going to take a look at cross sections of three-dimensional figures. And so anytime we take a cross section of a solid, it's always going to create a two-dimensional object like squares or rectangles or circles or triangles, something along those lines. So we have our five main solids. We have the sphere, the cone, the pyramid, the cylinder, and the prism. And so we are going to talk about the different ways that we can do the cross sections on those. So if we're going to start with the cube, it's a specific type of prism where all the sides are equal. No matter what type of cross section you create, even if it's diagonal, it's always going to be a square. The cone, if we cut that diagonally through any part of the cone, with the exception of the vertex, it's going to be a trapezoid. If we bisect it through the vertex, it's going to create a triangle. So only through the vertex is it a triangle. Anywhere else, that top is cut off, so that's why it's a trapezoid. If we cut it horizontally so that it's parallel to the base, it's going to be in the same shape as the base, just smaller, because they're going to be similar in size. So that would be a circle. And then if we talk about a cylinder, remember that a cylinder is kind of like a big cake. If I cut a big cake in half, then you're looking at a rectangle. And then if I cut it parallel to the bases, then that's going to create that circle. Now these next three about the rectangular prism, it's really, remember on a rectangular prism, all of the sides are going to be rectangles. So any two sides that are parallel could potentially be the two bases. So whatever two bases that you're cutting between, the cross section is going to be equal to those bases in shape. So if I look at this one, see how the two bases are these really big rectangles? If I cut between those two big rectangles, then my cross section is also going to be that big rectangle. If I cut it horizontally between the top and the bottom, then my cross section is also going to be that smaller rectangle that is parallel and congruent to the top and the bottom. If I cut it vertically in half, then it's going to be parallel to the front and the back. So it's going to be equal to the rectangle to the front and the back. The next example is the hemisphere, and anytime you slice that horizontally, it will create that circle. And in the last row on this page, we have a rectangular pyramid. And if you cut that rectangular pyramid, it's going to create a triangle. And if I cut it horizontally, it's going to be parallel to the base, so it's going to be a square. And then finally, the next page has the last couple on there. Anytime you dissect, or I'm sorry, you slice a sphere, it's always going to give you a circle. And then the triangular prism is where the two bases that are congruent are triangles, but all the other sides are rectangles. So if you slice it between those two triangles, then so that they're parallel to those, then it's going to be equal to the triangle, as in this case. So if I cut between those two triangles, it's going to be a triangle. If I cut between, or if I cut through the two bases, then it's going to be equal to the rectangle. For the triangular pyramid, if I cut it through the vertex, that's the time where it's also going to be a triangle. Anywhere else that you slice it vertically besides the vertex is going to give you a trapezoid similar to the cone that we saw earlier. And then if I cut it horizontally, it's going to be parallel to the base, so it's going to be a triangle, just smaller. And then these are just some unique dissections of cones. We're not going to take a focus on this one, but if I cut the top of a cone, then it's going to be a cylinder. If I cut it diagonally, it's going to create that ellipse. If I'm going to cut off either diagonally or horizontally the part of the cone that is not through the vertex, then it's going to create this parabola. So you can kind of take a look at it better in the example I scratched out. Notice that if it's vertical through any of that rounded part, then it's going to be that parabola shape. The only time it's a hyperbola is if I have two cones connected to each other to that point, then I'm going to have the two parabolas that are symmetrical to each other, and that's what makes it a hyperbola. So now let's go ahead and take a look at the examples. In number one, we have to slice this vertically. And notice that it has 5 sides. So it's going to be pentagonal. And because there's 2 bases, it's going to be a pentagonal prism. Okay. So if we cut it diagonally, that means the shape of the cross section would be a rectangle. If we cut it horizontally in between the 2 bases, that means it's going to be a pentagon. Number 2, we have an example of a triangular pyramid because all the sides are triangles, there's no rectangles. That means if I cut it vertically, anywhere but that vertex, it's going to create that trapezoid. And then if I slice it horizontally, it's going to create the triangle. And the second row, number 1, again, anytime we have a sphere, any cross section will be a circle. In the next example, we have that cylinder. If I cut this cylinder vertically in the orientation it is right now between those 2 bases, then it's going to create a circle as the cross section. If we slice it horizontally through the bases, that's where we get the rectangle, is the cross section. And then finally, these last 3 examples is rotating a triangle, a rectangle, or half a circle around, or a semicircle around an axis. What shape does that create? So in our first example, we have this triangle, and if I rotate it around, you'll see that it creates the cone. In the rectangle, if I rotate it around, you'll see that it creates the cylinder because it has the 2 circle bases. And then finally, if I rotate a circle around an axis or a semicircle, you'll see that it creates that sphere. But all 3 of these are similar because all 3 are going to have some sort of circular answer to it, because anytime that you rotate something 360 degrees, it's always going to be a circle. So I can't have any straight edges on any rotation of a 2-dimensional object when it creates a 3D figure. So again, the triangle was a cone. The rectangle being rotated was a cylinder. And then the semicircle was a sphere.